So when we look at the severe weather for today, right, we have a marginal risk like we talked about in a previous video in the Ohio Valley into Pennsylvania, um, in those areas, right? West Virginia, parts of Maryland, and let's see, Kentucky as well. So, and Indiana. So we look at the risk again. Let's review that real quick. Tornado risk, we got our marginal 2% tornado risk in this area in the green here, right? And we also have a hail risk in a little larger area, okay? And we also have the wind risk in that larger area. So going back to the categorical here, and we have thunderstorms surrounding that, okay? So what's driving this? It looks like we got a cold front pushing the south here. You see a little dip. This is 700 millibar heights, right? From the NAM model. Not that overly impressive, right? But we look at 500 millibars. There's, subtle height falls here. We go a little bit further. Let's see here. Parameters 850. You see a little bit of a dip here. Looks like a surface low, maybe going through the flow here. All right, which ramps up the low level jet a little bit here. So we look at let's look at the surface real quickly here. Um, dew points, not overly impressive here, although we could get in the 50s and 60s, the 50-degree dew points up in this area, which is pretty marginal for tornadoes, right? So, that's one of the limiting factors here with this. Temperature, plenty warm enough, and the dew point spread isn't that that high here, but overall, that's why we got a marginal risk here. Really not a lot of thermodynamic concerns, right? So let's look at some severe weather parameters with this real quickly. Bulk shear. I don't know, guys. Let's see here. The shear values, mostly out of the north here, with this, right? So as that cold front moves through, let's look at, let's see, mixed layer CAPE energy in the atmosphere. And we look at mixed layer CAPE to help determine the total amount of energy that's available. So realistically, in this area, there's plenty of energy, right? But whether or not we can get surface-based convection is going to be a question here. So when we talk about CAPE, that means energy, right? And then we talk about kinematics, that means wind, right? So a couple of parameters that help us look at whether we get supercells in this area is the supercell composite, which shows this as well. It's maximized around 5 p.m. today, 6 p.m., okay? It's not zero, but it's not overly impressive either. Significant tornado parameters, we have an enhancement of that too, although not that high, right? So, I mean, and there's our bulk shear again. So let's go to so on the right here, we have the HRRR model. I'm going to go through the different short range models here. Right, by 2 to 5 p.m., we could have some storms coming through the Ohio Valley here, but the HRR really is not really showing much of anything here. Maybe on the northern fringes of this, some better chances of storms, right? But let's go to the NAM 3-kilometer CONUS. Shows some convection going here, mostly shallow though. Not very impressive, all right? But if we can get some storms of fire, maybe a little further south here. I mean, like I said, the temperatures and dew points aren't that impressive here. HRW FE3, not as high resolution, pretty much shows the same scenario here. And the Rufus, which is another short range model, pretty much the same scenario between 2 and 5 p.m. The storm moved through. Now, we a little bit further out into the evening, maybe when the low level jet cranks up, we have some rotating updrafts here on the backside of this. Okay, so this is the time frame of interest when we get into the overnight hours. Okay, so interesting that shows that. HRRR, not as bullish with that, although it does have some stronger convection here Friday around 10 p.m. See how the convection kind of builds in behind it here. So we have that initial push, and then that short wave comes through, and it hits the convection here. So, NAM 3 kilometer, see behind here, later in the evening, overnight, some convection here, firing up, but no rotating updrafts in here. But you see here we have the initial push, and then the convection behind it. Let's look at one of the MPAS models here, see what it shows. It doesn't show much of anything firing behind here that's of note, but overall I think the first push is in the afternoon is not going to be noteworthy, but overnight, when we get to the overnight hours, which kind of stinks, but you know, you're going to have a higher threat of severe weather. So moving into day 3, Saturday into Sunday, we have some storms popping up here in the Tennessee Valley, North Georgia, and along the South Carolina-Georgia border here. All right. And as we move our view to the mid-Atlantic for a severe weather area of interest on the left here, this is the Rufus model, right? Storms ongoing here in the southeast. They move offshore, and we have a short wave trough moving through the east here. And you see it moves through the area of interest pretty quickly, right? Overnight, this is 2 a.m. So the timing of this is overnight hours, okay? And this model shows not a lot of activity here. I mean, no rotating updrafts really, right? But let's look at a few parameters associated with it just to start with here. Supercell Composite, not showing much of anything. Standard tornadoes, not showing much anything here. Let's look at dew points here. A couple other surface parameters that help us determine instability. Dew points in the 50s and 60s here. Not overly bullish on this. Now, if we switch to another model, let's take a look. All right, like the NAM 3 kilometer, see if it goes out far enough. It goes out to Sunday at 6 a.m., which isn't far enough, right? But go to the NAM regional. Sunday 8 a.m. It wants to bring 60-degree dew points into this area. So let's see what parameters it has for severe weather here. One thing we look at, and we talk about this, is mixed layer CAPE, which is energy in the atmosphere. So we have some CAPE values that are somewhat elevated here, just to this right around our area of interest on the left. So if these can be realized, we get some convection firing. These are plenty of energy there, right? So let's look at our shear in the atmosphere. There's some shear involved with this as well. Okay, you see it's maximized as it comes to the south. All right, and 0 to 3 kilometer shear. Quite a bit of shear here as that pushes through as well. A boundary there pushing to the south. So I don't know, guys. There's still some mixed signals with this here. So we'll have to see how the models play out as we get more into the short range. But generally, this looks to be an evening to overnight event as well. And I'll refine my forecast with this and talk about it more tomorrow and Sunday morning as well, because we'll have plenty of time to see how this evolves.